Okay, let's start with the example that we left off from Monday. Let's have a quick look how it looks like. So if you look at this program over here, this is how we did things unconditionally. Let's say without if statements and also without any loop. We simply just calculate whatever the user gives us as the radius and then calculate the area accordingly. What if the value is negative? So that's really the problem we're trying to solve. So this is what we want to extend in order to make the program more useful. If the user can keep entering the positive radius value to us, we can keep calculating the area for them. Otherwise, as soon as they enter anything that's not positive, we can exit from the loop. That's something we would like to program. Okay? So what we saw last time on Wednesday was this particular extension over here. We simply say if the radius is larger than or equal to 0, as long as it is true, we can keep serving the user. Otherwise, we got to exit from the loop. Okay, guys, we already started, right? Okay, so now I would like to present to you, so this is something we already did on Monday. And we already tried several test cases. What I would like to show you is, I want to show you another two variants which will be more useful for your purpose for the lab test and also the future lab exercises. We want to somehow, rather than writing out this condition here directly, you may want to use a Boolean variable to actually capture the condition. Okay? That's something I want to show you. And then I'll show you two different versions. Okay? That's kind of the plan. Okay? Let's start with this. And then after this, we'll go very quickly to summarize the loops syntax, and we'll go to array. Okay? That's the main topic for the rest of the loops lecture. So now the first version I would like to show you, let me show you the code structure very quickly, and then I'll trace the code together with you. So the two versions we're going to have will be equivalents. Okay? All right, so now let's have a look. Now version number 1, the one I highlighted in yellow is basically the change I'm making. So let's just focus on the change first, and I'll trace the code together with you. If you look at line number 3 over here, over here, we simply declare a Boolean variable to see if the user's input is positive or not. If it is positive, that simply means the radius is larger than or equal to 0. And then we simply put is positive, the Boolean variable itself, as the state condition. Okay? And then at the end of the loop, we simply want to do some updates to say is positive is simply updated to whatever the radius value the user newly entered larger than or equal to 0. Okay? That's the structure, but we're going to trace it to see exactly what it means. The second version I'm going to show you is kind of symmetric. Rather than using a Boolean variable saying it's positive, let's say I simply say it's negative. So I simply say it's negative is going to be if the radius is less than 0, which means it is not valid. Which means as soon as the user enters something that's not negative, then we should exit from the loop. So now you can see this is a little bit tricky over here, but let's pay attention to it, and that will trace with you. Line number 4, we say as long as it is not the case that it is negative, then we're going to keep in the loop. Otherwise, we're going to exit from the loop. Okay? And then in line number 9, we say it's negative, it's simply just going to be updated by radius being less than 0. Okay? So that's the general structure for the two versions. I claim that these two versions are equivalents. Okay? But now let's see exactly how it works. And then I will ask you one question to think about, and then we'll solve it together. Okay? Let's move to iPad now. So these are the two versions of the code I just mentioned. Okay? So again, the thing you really want to get used to is you have a Boolean variable over here and also over here. And then the truth of the Boolean variable corresponds to some Boolean expression over here. In this case, it's larger than or equal to 0. In this case, it is less than 0. As you can see, these two conditions over here are simply negation of each other. Right? We talk about a negation for explanation mark. And then here, the state condition is as long as it is positive, we're going to keep going. Here we say as long as it is not negative, we're going to keep going. And for both versions over here, we have a line over here to make sure every time the user enters a new radius value, we're going to calculate to see whether this variable should be true or false. We're going to make sure it is updated always. And also similarly for the second version, you also have the radius whether that's less than 0 or not. Okay? So that's kind of the general structure. Okay. So now let's trace these two versions by using some test cases. I'll just maybe, I got 3 test cases. Let's see how long it would take. At least we'll do 1 or 2 together. Okay? Now, number 1. Let's see test case number 1, which is very easy. Let's say the user is not very well behaved. They simply just give us some negative value, in which case we should not serve them. We should really exit the loop right away. We should not even go to calculate the first time even. Okay? Let's see exactly how this will execute. If the user enters radius -3 for version number 1, radius over here would simply just be -3. -3 larger than or equal to 0 is going to give us false. That means we got false over here, for it's positive here. And then when we evaluate the loop header in line number 4, it's positive, is going to be false. So now we have a critical decision to make. Should we go into the body of the while loop? We shouldn't, because we know that the meaning for the while loop is as long as the state condition is true, we're going to go into the loop. Otherwise, we exit right away. So in this case, it is false directly, so we're going to exit from the loop and then go directly to the outside the loop and see the first line. And they will simply say error, negative radius value. Okay, that's the very first test case. What about the second version? Let's see how the second version works. Since I claim that the 2 versions are equivalent, they should work the same. Let's see. And now for the second version over here, we're still going to use -3 as a user input. So now it is -3 over here. -3 less than 0 is going to give us true. Okay? So this makes sense because we ask if the number is negative. It is, so that should be true. However, when we evaluate this particular while loop in line number 4, what do we have? So you can see this is not is negative. So now it's negative, we already know it's simply just true. And not true is going to give us false. So we still have the same result. It's still false. So they are equivalents. Okay? So once we know it is false, we're going to skip the body of the loop and go directly outside the loop and go to the first line. So we're still going to say error, negative radius value. So from test case number 1, if the user enters something that's negative right away, in both versions, we exit from the loop right away. We don't even calculate once for them. Okay? So they're equivalent for test case number 1. Okay? But both versions are equivalent. You want to get used to both. Whichever you want to write for your lab is completely up to you. But in the quiz or in the exam, you want to know how to analyze the behavior for both. Let's do one more, okay? And the pink one, I'll leave that as an exercise for you, okay? Let's do one more. What about test case number 2? So now this is the outline. Let's say the user entered positive number for the first time. So which means we're going to calculate area for them for the first time. And then we ask them, would you like to continue with another input value? Let's say they enter something that is illegal, -3. In which case, we should not calculate for them for the second time, right? Logically speaking, that's the way it should go. We want to see if this behavior can be exhibited in the 2 versions, okay? Let's see. So now, the first time, let's try version 1. The user is going to enter number 2. So 2 larger than or equal to 0 is going to give us true. So I'm going to put true over here. So notice the color is true, right? And then now, when we evaluate line number 4, is positive. In this case, it is true. So now we know that as long as the state condition is true, we're going to go into the loop. So that means we'll go into the loop, and then we're going to do the calculation over here. Okay? So these 3 lines, 5, 6, and 7, are simply just going to calculate the area, right? So over here, we're simply going to do, because it's 2. So 2 times 2 times 3.14, whatever the result it is. Okay? And then now here comes the critical points. We are going to ask the user to enter another radius value. That's why we got another input next double. Okay? So now, let's say for the second value, the user enter -3, let's say. So this is illegal, which means we should not calculate the area for -3. We should not, right? So now let's see if that would be the case. So now input next double, the second integer is going to be -3. Okay? So now what do we expect to see? We expect to see that once we go back to the header of the while loop in line number 4, the state condition should evaluate to false rather than true, right? How does it happen? That is why line number 9 is very, very critical over here. So now we're going to reassign the value for is positive, and now radius, the new value right now is actually -3. So that means we got -3 over here. So -3 larger than or equal to 0 is going to give us false. So that means if it's positive, it's going to be reassigned to false after line number 9. So that means when we go back to line number 4 to reevaluate is positive over here, it's simply just going to be false. What does that mean? Exit from the loop. Don't do the second calculation for them. Okay? So after it's false, then we're going to exit from the loop, and then we're going to say error, negative radius value. So notice the difference between test 1 and test 2. For test number 1, we don't even calculate once for them. For test number 2, we calculate just the very first positive number they mentioned. As soon as they enter a negative value, we're going to exit from the loop. Okay? So now let's see if the second version is going to behave the same. If they are, we can now more sure they're equivalents. Okay? Are we okay so far? Okay? Let's try very quickly version number 2. Okay? So now for version number 2, let's say, again, we're going to try 2 and then -3. Okay? The idea will be very similar. You just have to know how to keep track of the Boolean variable. Let's try. So now the very first value the user entered will be just value 2. And then, so that means we got this particular Boolean expression to evaluate 2 less than 0 is going to give us false, which means it's negative, it's just going to be false initially, right? And then when we evaluate line number 4 for the header, we have not is negative. In this case, is negative is simply just false, right? Not false will give us true. Okay? So that would be true. That means we're simply just going to execute line number 5, 6, and 7 to calculate the area for this particular value 2. So we're going to calculate 2 times 2 times 3.14. Okay? So far so good. Seems to be equivalent so far. Now, let's say the user for the second value they're going to enter -3, which is illegal. So now that means the input the next double for the second time is going to read in -3 from the user. Okay? That means the radius would now be -3. So now let's try to reevaluate. So that's why again line number 9 is really important. It has to keep up to date what the user has entered so far. So now you have -3 less than 0, which will be true. That means it's negative would now just be true. Okay, let's keep that in mind. So now when we go back to line number 4 to reevaluate the header of the loop again, so now not is negative. How would that be? It's negative, we know that it's simply just true. Not true will just give us false. That means for the second time it's going to give us false. And then we're going to exit from the loop directly and then go outside the loop and go to the first line outside the loop, which will be error, negative radius value. So if you compare the two runs for the two versions, they are completely equivalent. Okay? As I said, which version to choose to write is completely up to you, but you should know how to read both versions. Any questions about this? Okay. I do have a question for you. I want you to pay attention to line number 9. Okay? Let me take only version 1 for example, and version 2, the argument will be similar. Okay? Now let's reevaluate this particular piece of code over here. Okay? It's really important to understand why this particular version may not work. So this is version 1. We simply got Boolean variable here again. It's positive over here, and then we got, as long as it is positive, then we're going to do something. Now, my question is as follows. Line number 9, as I mentioned before, is very critical for us to to actually exit from the loop as soon as the user enter just a negative value. What if I simply delete this line here? Okay, I'm simply going to cross it out like this from my program. So line number 9 does not exist anymore. So now, is the program going to work as before though? Think a little bit more clearly, it's really important. I would say this one here is even more important to understand than the previous version. Okay? It's a very common mistake. Let's try. What I will try to do is, I'll try to do test number 2, which we just did. Okay? Remember what happened in test number 2. We will calculate for user for the very first time when the radius value is positive. However, as soon as they enter something that's negative, we don't calculate for them anymore. Instead, we exit from the loop and print out an error message, right? That's what we did. So now I would like to trace this together with you to see how wrong it is, okay? So now what I will do is I'll simply just use different color to show you. Let's say for the first time, the user simply entered the value just 2, okay? So that means for this initial keyboard input here, we simply just get 2. So that means radius value is simply just 2 to begin with. And then 2 larger than or equal to 0 is going to be true. That means it's positive is simply just going to be true. Okay, so far so good. And then while is positive, in this case simply true. While true, what should we do? We should go inside the loop to execute the body of the loop. And then we're simply just going to the loop and then execute line number 5, 6, and 7. And then we're simply just going to calculate the area for 2 times 2 times 3.14, whatever value it is, right? So this will be output to the console to say what the area is. So far, so good, okay? Now, here comes the critical points. Let's say the user is being prompted again over here. And now, this time, they enter something that's illegal and shouldn't be taken as input, right? If they enter -3 over here, and apparently radius will just be -3, okay? So now, given that line number 9 was already deleted, are we going to calculate for them again? Yeah. Why? Let's try. Because you can see, so now we are reaching the end of the loop over here. That means we're going back to the header of the loop and then try to reevaluate this particular state condition, which only depends on its positive. Has this particular Boolean variable been updated just yet? No, it stays true, right? So that means it's positive over here, it's still true over here. We didn't really update it as before. So that means we'll still go into the loop and execute line number 5, 6, and 7. And then we'll simply just calculate -3 times -3 times 3.14. And we simply output the area for -3 radius. And that is wrong. Okay, let me just recap very quickly. If you think about the variable as a box. Is positive is something that we would like to maintain is a Boolean flag, Boolean variable to see whether we should stay in the loop or not. The very initial value for is positive when we evaluate over here is simply just true. Okay? However, when we try to read in the very second radius over here, which is -3, after that, even though it's -3, it's being stored. But we didn't really execute line number 9 anymore because I deleted that. That's my question to you, right? Originally, would it still work if line number 9 was deleted? In this case, because line number 9 is not there anymore, so this true stays over there. So that means when we try to evaluate the header of the loop for the second time, it will still be true. So we're still going to the loop body. That's not right. Okay, it's really important for you to understand why would it not work when line number 9 is not there. So what's really worse? Since in this incorrect version over here, we don't have line number 9 anymore. That means your is positive is always going to stay true. That means you never get a chance to exit from the loop. So this is something called infinite loop. Infinite loop in the sense that it will just execute the body of the loop for an infinite number of times. This is something you want to avoid for your lab exercises. This is a very common mistake, so be careful. Okay, any question about this? Okay, good. So now let's move on to something light, and then we'll talk about array. Okay, just converting the syntax over here. I'll show you very quickly. So as I mentioned before, the while loop and for loop, they are pretty much equivalent to each other. So you really have a choice, either to use the for loop or while loop. It's only a personal preference. In the lab or in the lab test, I wouldn't enforce you to actually say which one to use. You got complete freedom. It's also possible to actually convert from one to the other. There's some general rule you can follow. I'll go over them with you very quickly. For a given while loop, because you simply got the state condition, Boolean condition over here, you can easily convert that into a for loop. In which case, you still have the 2 semicolons over here, but the first part is simply empty. And the third part is also empty. simply copy over the Boolean condition over here. And that's how you convert from while loop into for loop. Okay? However, I would say if you simply don't know how many times you're actually going to exit the iterations, use a while loop. You only use a for loop when you know for sure the number of times you're going to execute the body of the loop. Okay? That's a very quick conversion tip for you. What about vice versa? How do we convert from for loop into while loop? Let's say here we got a for loop over here. We have initialization, we have the state condition, and we have the updates part. Remember, let me mention again. The third part for the for loop simply means every time if you want to update the loop counter, do it at the end of the iteration. Okay, that's always the case. So now if I convert that into while loop, easy. I simply move this out into here. Okay, move this outside the while loop, and then copy the state condition over here into the while loop, and then move this one to the end of the iteration. Okay, and then whatever you have before can just stay the same. Okay, that's just another conversion. Again, whether to use for loop or while loop is completely up to you. Okay, okay, this one's simple. So now I want to talk very briefly about state condition versus exit condition. Again, the reason we are talking about this kind of a difference is it will help you doing some analysis on your loop, because sometimes you might run into some logical error without knowing it. Okay, let's do some general rule, and then we'll give you one example. We talked about logical rule before, right? Let me review very quickly with you. Let's say we got P and Q. They are simply just Boolean variables, right? Just Boolean value. P can be true or false, and Q can also be true or false. And we talk about this rule when we talk about selection. Let's review very quickly. If I have P and Q, and then I say it is not the case, P and Q is true. And we mentioned that it's simply equivalent to the right-hand side, right? P and Q is only true if P is true and Q is true. If I tell you that the conjunction is not true, what does that mean? That means either the left-hand side is not true or the right-hand side is not true. So that simply means, okay, let me show you this a little. Let me move this low. Okay? So now that simply means either P is not true or Q is not true. Okay? That's the rule we just talked about. And also very quickly, what about when we have over here P or Q? Okay? And I say it is not the case P or Q is true. Remember, when can P or Q be true? P or Q is true as long as one side, but it doesn't have to be both sides, is actually true, right? But now if I tell you that the disjunction is simply false, it is not the case. That simply means both sides are actually false. Okay? So this is simply equivalent to the left-hand side is not true, and also the right-hand side is not true. Okay? It's a very quick review from the previous lecture. Okay, so now this is completely applicable to our context, because our state condition can very likely contain some conjunction with disjunction. You will see that in many cases in the maybe following lab, or maybe in your lab test number 2. Okay, I'll talk a little bit more about it later. A very simple question. I'll give you a concrete example in the next slides. Let's say currently I say that I have a while loop over here, and I say that I will do action number 1. I will repeatedly do action number 1 if P is true and Q is true. Okay, that's what I'm trying to say. So now, given this, what does it really mean? So when, under what circumstance would I actually stop repeating action number 1, which means I will exit from the while loop? What does that really mean? I know that as long as P and Q is true, I'm going to keep repeating action number 1. So when should I stop repeating action number 1? That means it is not the case that P and Q is actually true. Okay, so this is the so-called exit condition. You can think about in general, when you are given some state condition, given that, okay, the exit condition is very easy to calculate. You will simply say the exit condition is simply just not the case. The state condition is true. Okay, just negation of each other. Okay. Now, similarly, if I have the second while loop over here, I say that I'm going to repeat action number 2 as long as P is true or Q is true. So what does it really mean when I stop repeating action number 2? that means it is not the case P is true or Q is true, right? So that means it is not the case that P is true or Q is true. So this is again the exit condition. Okay, it's a very little bit abstract over here, but I'll give you one example. Okay, but these two are really important properties that we learned before. I'm just applying that into a different context for the for loop. Okay, so now let's do one exercise together. I want you to look at this particular while loop over here. Okay, it compiles. Okay, well, of course it compiles because for the state condition there, we simply got some disjunction over there, right? We say that x should be in between, x should be larger than or equal to 10, or x should be less than or equal to 20, right? So now we want to know if this loop has any logical error. Logical error in the sense, well, typically what can be logical error for a loop? When the loop doesn't terminate ever, that's a logical error, all right? What can be a logical error for if statements? If you got two branches, but you never go to one branch, but you always go to the other one, that's a logical error, okay? So now, can we have a look at this? And the diagram I started with over there is some hints to you. So that's how you should sketch the idea when you're given this problem here. You can think from both angles. You can either think from the perspective of the state condition, like under what circumstance am I going to keep repeating whatever that's inside the body of the loop? Or under what circumstance am I going to stop repeating? Okay? If I never stop, then that's not good. If I always repeat, that's also not good, right? So these two are really equivalent notions. But let's have a look. Let's try to see from the state condition perspective, okay? So now we have two conditions over here. So let me just highlight them using different color here. So let's say the first one, let's say yellow, 10 less than or equal to 10. So this is exactly just over here, right? So that means x is larger than or equal to 10. Okay, that's exactly this line over here. X is larger than or equal to 10. Agree? What about the second one? The second one over there, I will use blue. That means x is less than or equal to 20. So x is less than or equal to 20. Do these two intervals cover all possible numbers in the line? They do. Okay? So hopefully you're very comfortable with this. We talked about this kind of interval problem for many times already. If you're still having trouble, maybe speak to me. Okay, I'll help you with that. Okay, so now since we're having disjunction in this case, we are saying that it's either this interval over here or it is this interval over here. So both intervals, if you add them up together, it's going to cover all numbers. Okay? So that means this particular notion over here is simply equivalent to true. So it's as if you say while true over here. So that means you always repeat this particular action. You never get a chance to stop. So that's one way to see that's a logical error. Okay, this is not good. So that means that means you always try to repeat. Always repeat the action. Okay, that's one way to look at that. Okay. Let's try to apply the logical law a little bit to see a little bit more clearly. Okay? Always repeat simply means you never try to stop. Okay? Let's see how these two equivalence notation can show up in this particular example. So now the question is, now let's have a look at this. So this is the scope for this particular while loop, which I'm trying to box over here. Okay? This is the scope for the while loop. Let's say this is the very first line outside the while loop. So now, if I can reach this line, that means I already exit from the while loop. So now, under what circumstance can I actually reach this line outside the while loop? Okay? If I can reach that line, that simply means the state condition simply evaluate to false. So the state condition is not the case anymore. Okay? So the exit condition over here, you can think about this condition here, simply means it is not the case 10 less than or equal to x, or x less than or equal to 20, right? That's exactly what we said in the second rule over here. I'm just applying one of them for you. Okay, you can just derive for others. So now, how do we simplify this a little bit to see more clearly? Right? We already talked about how to simplify this, right? First of all, simplify this into, it is not the case, 10 less than or equal to x, and then swap from disjunction to conjunction, and not the case, x less than or equal to 20. Okay, so far so good. And then let's simplify just one step further. And then here we got less than or equal to, over here, we got negation, so it's going to be 10 greater than x. Okay? And also, over here, we got less than or equal to, and then we got negation. So that means you can switch the sign. So that'll be x strictly larger than 20. Okay? So this is the circumstance under which you're going to exit from the loop. Is this ever possible, though? We want to see. Let's try. Again, let's try the following. Let's say this guy here is yellow, and in which case, x is less than 10, which is over here. X is less than 10. And also, let's try another one, which is blue. So x is larger than 20, which is over here. So now we are saying that they should be satisfied at the same time. As you can see, there is simply no number in the line which can be in this interval and also in this interval simultaneously. It's simply not possible. Okay? So what does that mean? That means this particular condition here will just be simplified into false. Okay? So that means we will never ever exit from the loop. Okay? That's another way to see why it is a logical error. Okay? So now what I want you to be good at, if you're given a condition for the state condition, you want to know what the corresponding exit condition is by applying these logical laws. It's really important because you want to know how to analyze the behavior for the loop. Any questions about this? So the main message from this slide over here is when you're given the state condition for the while loop, if I want you to tell me whether there's any logical error, meaning that if there's any infinite loop possibility, what you want to do is you want to see from the state condition, draw some diagram to see if that will be equivalent to true. That means you will always repeat. Or you can apply some logical rule to see what the exit condition is. If that simplifies to false, that means you never ever exit. In that case, that's also infinite loop. Okay? So these two notions are completely equivalent. You want to get comfortable with that. Questions for this? All right. So now that's good. So we talk about conversion already, so you can go over that. And also we talk about state condition versus exit condition by using the two logical laws. We also cover that. And also this is something you want to get used to. I also show you the detailed steps over here, which I also did in the iPad. Okay, if no question, let's move on to the most important topic for loops. And this would be, the header is cut off. I'll read it to you. The header simply says problems, data structures, and algorithms. So this single slide, it just gives you a little bit introduction to the context for programming, especially when now we got the context for array, which is really important to cover. I'll do as much as I can. I got about 15 minutes, but I will release the tutorial videos hopefully Thursday by lunchtime, so you can see more about array, and you can do some exercise for the coming lab. Basically, let me just go over this slide here, and I'll give you a little bit of context why we are doing this. Okay? Now, we talk about just some terminology for you to get used to. So I'll keep mentioning these terminology to get you used to the field. One is about computational problem. So what is really a computational problem? It's a problem that will require you to give a programming solution. That's a computational problem. And typically for a problem, you just want to know what the input is and what the output is. You're already doing this for your lab test 1. When you're given the problem description, that's the input. And when you want to really produce some program that will generate some output to the console, that's the output, right? You got input, you got output. One example would be, which we'll solve together. Maybe not today, but maybe next Monday or in the tutorial video. So now, a very common pattern for problem would be, you're simply given, I might use different words. I might say a sequence, I might say a list, or I might say a collection. Basically just a collection of things. You might be given a sequence of numbers, right? It can be 5 numbers, it can be 10, it can be 100, it can be a million numbers. Doesn't matter, just a collection of numbers. Okay, it's the input. What's the output? We want to know out of the list of numbers, what's the maximum value in the number? It's a very typical problem to solve, also very practical problem to solve, right? Given a collection, you want to know what the maximum member is in the collection. Okay, that's just one example. And we also talk about the instance of the problem. Instance simply means example. In the lab test 1, for each problem there, I just give you a few examples there. However, one thing you want to note, whenever you want to give me a programming solution, you should not program specifically just for the examples I give to you. You want to make your solution as general as possible, so that if I give you any input values, it will just calculate and give the right output. Okay, that's something you want to keep in mind. Okay, okay, that's an instance of the problem. And now, data structure. Since this course is still introductory level, so the only data structure we cover will be called array. And maybe we'll talk about a little bit about two-dimensional array, which is also very fun to study, maybe towards the end of the course. Data structure simply means you have a particular way to store and retrieve data from the computer memory. However, the way we study that is very conceptual, but I'll show some diagram to you. Okay? Basically, data structure, and in our case, whenever I talk about data structure for this course, I just mean array, okay? A sequence of things. You may have learned about something like that in MATLAB, but I think in Java you can do many more things using array. Okay? It's mainly for you can get access to it, or you can do some modification to the array. Okay? We'll talk about many examples from now on. Finally, algorithm. You may have heard about this buzzword up to now. Algorithm simply means given a problem and given a particular data structure you can use, you want to have a step-by-step program to really see, given the input, how can I do step 1, step 2, step 3, and step 4, and eventually I can get to you the output. It's the instruction set for the computer to execute. Okay, that's algorithm. Okay? For those of you who might take some advanced level algorithm course, that's exactly the study you might have. Okay? But if you know, that's okay. At least we can give you the basics for this course. Again, that's why I said for this course, the most important learning outcome is computational thinking. Okay? And for example, if you study electrical engineering, I'm pretty sure you will learn about C programming language later, in which case you definitely had to use lots about array. So I'm pretty sure this course will be very useful to you. Okay? So now, solution is simply, algorithm is simply a solution, and now the important thing is about sequential execution, and also you got for your algorithm is simply just going to make use of some data structure, in this case array. Okay? But we'll try to give you many examples, but you can keep reviewing these slides. This slide just gives you all the terminology you should know for the rest of the loops lecture. Okay, so now let me give you, for the slides, I already got everything on the slides. You can check the slides, but I'm gonna, for now I'm gonna use the iPad to give you some syntax, some very crash course. I got about 10 minutes to do it. I'll see how much I can do. If I cannot finish it, I'll put it in the tutorial video for you. So now, we talk about array. Let me show you one more thing on the slides quickly. When we talk about array, this is how you visualize it. It's very straightforward visualization. An array is simply just a list that looks like this. You have many cells. You have the leftmost cell. You also have the rightmost cell. And one thing I want to really get used to is, for every cell, if I want to refer to them, I can refer to them using their position. For example, you can see this is the very first cell that stores the number 940. And this is the third cell that stores the number 830, okay, for example. However, the way we refer to the position in the array start with not 1, but start with 0. So there is some insight into the computer memory, which I will rather explain to you in the tutorial video. I can use more time to explain to you properly. But for now, for the purpose of the lecture, the way you refer to a particular cell or elements in the array, if you want to say, I want to refer to the fifth one, go to index 4. If I want to go to the first one, go to index 0. Okay, we'll get used to this notion. Okay, and then one more thing to say. Whenever you want to have an array, want to store a collection of stuff, all the stuff must be of the same type. You cannot say, I want to store an array where the first element is a Boolean, second element is a character, and third element is a string. You cannot do it. You want to commit to a particular type. So now let me show you some syntax very quickly, and I'll go to example. You might say, there's some syntax I will just introduce in just one moment. You can have an array of integers, which means store integer only. You can have an array of doubles, an array of characters, an array of strings, and an array of Booleans. Okay, so these are the array types you will have to focus on at least until lab test 2. Okay, that's exactly the coverage for lab test 2. Okay, but we'll have a few lectures to prepare you for that. Okay, so now let me switch to iPad and then tell you the syntax for the array. So now let's first talk about the first example here. We simply get an array of integers. Okay, as before, if you want to store things, you have to declare some variable name, variable type, and also give them some initial value. That's what you have to do. And then you may reassign the variable for as many times as you like. That's kind of the principle. It doesn't change. That's why it's called principle. Let's just say we want to have this particular array. Let me notice one detail to you. There's a reason I do it. So now let's say I want to create a variable for the array called IA, standing for integer array. Just call it IA. It's going to be the variable name. And then I simply say IA simply points to somewhere of an array. So there's a reason I put the arrow like this, because when we talk about classes and objects after the reading week, we had a consistent notion of drawing things. So for now, just take it for granted. So we simply got integer array. It simply point to a sequence of stuff over here. Okay, we got index 0, index 1, index 2, index 3. So now, question for you. Given that our indices start with 0, and the last index is 9, how many elements do we have? Okay, you want to be quick on this. Okay, so now you can see this is the last index. That means we got 10 elements. Usually the last index tells you that if you plus 1 to the last index, it's going to be the number of elements, because we start the index with 0. Okay, that's something you want to get used to. Okay, so now let's see how we can create this particular array in Java. Let's see that very quickly. Okay, so there are basically there are 3 different ways you can do it. Okay, so now let me do the first 2. In this case, we have no pattern on the store values. What do I mean by that? Well, let me use a better color here. When I say no pattern over here, if you look at the numbers over here, it's 940, 880, 830, 790, right? There's no pattern between the numbers over here. On the other hand, let me give you another example array. If you look at the second array over here, also integer array IA. So now, if you look at the numbers over here, the one in green, 7, 10, 13, 16, 19. How does it look like to you? It's more like a, what kind of sequence is that? Arithmetic sequence, right? You remember we talked about it in lab test 1? Okay? So now, anytime when you see that the way you want to initialize the array, if the elements followed a particular pattern, that means you can use a loop to initialize the array. Okay? I'm going to show you 3. Okay? So that's why, for this second example here, we do have a pattern, so we don't have to follow approach 1 and approach 2. Usually approach 1 and approach 2, they are more verbatim to write. But for approach 3, when you have a pattern, you can use a loop. Let's just go over them very quickly. So now, we're going to talk about declaration, and we're going to talk about initialization. Let's do approach 1 and 2. They're very straightforward. Approach 1 is very easy to see. Okay? Now, how do we declare an array? First of all, put the type for each element in the array. In this case, every element in the array is just going to be an integer. Put that first. Okay? The same as before. But now we want to say this particular variable is going to be an array rather than a single integer. So now here's the syntax. Put opening square brackets and closing square brackets. I don't know MATLAB. I'm not sure if you do the same in MATLAB. I'm not too sure. If not, that's okay. Just you got to learn this new syntax. Okay? So this is a type. Okay? Simply tell you an array of integers. Okay? And you can simply change this particular type to Boolean, to character, to string, whenever you want to change the type for the array. Okay, that's declaration. And then you give a name of the variable IA. Okay, and then I want to initialize that into something. Okay, since for now I know for sure the array of numbers I would like to initialize that into. So I can simply do left curly brackets, and then I simply enumerate all the values out. I can say 940, and then 880, 830, let me put it down quickly. And then 750, 660, 650, and then 590, You definitely can do it in one line. I just don't have space. 440, okay, all the 10 elements, and then close it with a curly brackets. So that's the first version, done. Okay, that's the easiest way for you to enumerate an array. Which one? Which semicolon? Yeah, so the semicolon here is really important because you can think about what we're trying to do here. Okay, let me highlight the syntax importance to you. You can see over here we're doing an assignment, right? You this one here? You mean this one here? It's a comma. Yeah, so everything in the array should be separated by comma. Okay? Everything over here is just a comma. Sorry about that. I could have drawn a little bit better, but it's comma. Okay? Just comma separated. Okay? When you see the tutorial, you'll see that's comma. Okay? Approach number one is very easy. Okay? It's called an array initializer. Okay? Let's do the approach number two. Okay? Approach number two basically is going to say the following. Rather than initialize the array in a single line directly, I can say let's create an array of size 10 first. And then I'm going to assign to individual slot of the array one by one. What do I mean? Let me show you the syntax. I can say integer array. I do the same declaration of the type over here. And then I will say int IA. Okay, so now it's assigned to. Okay, so now there is some new syntax you got to learn. You have to put a new keyword called new. When I underscore that is a new is a keyword, new. Okay, new, and then integer array. However, over here you are required to put a size of the array. And one thing to keep in mind: once you create the array to be a certain size, typically you don't want to expand it. So make up your mind at this point. In this case, we know we just want an array of size 10, right? So I'll simply put 10. So what does that mean? That means, yes, I'm simply creating an array of integer of size 10. So now what I want to do is I want to assign to individual element in the array, starting from index 0 to index 9. Okay, how do I do that? I can simply say IA, okay, so that's another syntax for you. Every time you want to refer to, yes, question? Huh? It's not empty. Okay, it's a good question. How does the array look like? Let's say after this line, after the green one, it's going to be something like this. Okay, I'll draw it here. It looks like IA is pointing to an array of size 10. 0, 1, 2, all the way to index 9. The initial value for each element is not important over here. Let's not go too much detail into that. Okay, I just create not empty array, but array of size 10. I'll talk about empty array a little bit later. Good. So now let's do the pink one over here. I'll just do one for you, and then I want to say now I want to assign 940 into this particular first slot. So now how do I refer to a particular slot by position? IA at position 0. Every time you want to refer to a slot in the array, use the square bracket notation, always the case, okay? And then this first position should be assigned to 940, semicolon. After this, I'm going to assign 940 exactly to here. So now, how many such assignments do you have to do for approach 2? 10. Okay? Let me do, you can do this, and then I can say IA at position 1 should be assigned to 880. Okay, you can do the rest. What will be the last one? That's important. What will be the last one? IA at position 9, right? Give me 1 minute, 1 or 2 minutes, and then we are done, okay? I will talk about approach 3 next time. The last one will be IA at position 9 is assigned to 440. So now one more syntax to show you, and that will be all the syntax you have to know for array, okay? So now, this last syntax over here, which is 9, you have somehow like a formula to write out, okay? Every time when you have an array, you can somehow to say IA dot length. whatever array you have, the name, you can always say dot and length. Spell that exactly like it is, L-E-N-G-T-H, length, okay, all lowercase. And now you can say IA the length minus 1. Why? Because over here you can see the IA integer array, the length is referring to how large this array is. In this case, it's simply just 10. 10 minus 1 is going to give you 9. So that's also equivalence. Okay, I will talk a little bit more about the various syntax, give you some reminder in the tutorial. Okay, any questions? Okay, I will see you in the lab.